Hello students. In last class we have discussed about some problems based on NLM and we had discussed in that class how to find out acceleration when there is no friction between surfaces. But now in this class we'll do some problems related to same how to find out acceleration, but now in we will consider that the friction is there between surfaces. As we know, acceleration is simply net force upon net mass. If we want to calculate acceleration, then just we have to calculate net force and net mass, as we had done in the last class. So first, let us know about friction. What is friction? Actually, friction is a force that opposes the relative motion of any object. Relative motion means uh, it opposes the motion of an object with respect to another surface on which it is placed. Right? Suppose, um, let us take an example. Suppose there is a block on the surface of mass m, and suppose there is a frictional coefficient between, or we can say we have applied a force F Newton on this block in this direction. If I am applying the force F in this direction, then with respect to this ground surface on which it is placed, it is having the tendency to move in this forward direction. So since it is having the tendency to move in this direction, so the force of friction will act on the block in the opposite direction. Let us consider it is small f. Let us take another example. Suppose a block of capital M is placed on the surface and the another block of mass small m is placed on the surface. And now if I have applied the capital force on this block, on the block of mass capital M, then what will happen? Actually, with respect to this ground surface, this block will have tendency to move in this direction, forward direction. So of course friction on this block will be in the opposite direction. So like this. Suppose it is F1. But if we talk about the this block of mass small m, then with respect to this surface on which it is placed, with respect to this surface, when we have applied the force F on the M, capital M, in this direction, and when it is having the tendency to move in this direction, then with respect to this capital M, this small m will have the tendency to move in opposite direction, right? And if it is having the tendency to move in this direction, then of course the friction between these surface will act in this direction. Suppose it is F2. So simply we can say friction is just the opposing force which opposes the motion of body with respect to another over which it is placed, right? So and the what how can we calculate the frictional force mathematically? As we know, frictional force is directly proportional to normal force. There are two types of forces: static friction and kinetic friction. So in case of a static friction, we can say Fs is directly proportional to normal force, and we when we take a constant here, it is mu n. Mu is a coefficient which is known as coefficient of friction. It depends on the nature of surfaces. In case of static friction, we can write here Fs equals to mu s n, and in case of kinetic friction, we can write Fk equals to mu k into. Now we are going to solve the same problems as we have done in last classes, but now we will consider the friction forces between surface. Suppose first example is here: a table surface and a pulley is attached on this at the corner, and a block is placed on the surface having mass small m1, and through a string over the pulley the another block is attached of mass m2. And let us consider the friction coefficient of the surface is mu, and it is given that m2 is greater than m1. Again the same problem we are having, that we have to find out acceleration, and as we know acceleration is simply net force and force should be along the direction of acceleration. If there is no component of force along the direction of acceleration, then we have to take first the component of force along the direction of acceleration. Net force upon net mass. There is no problem with net mass, simply it is m1 plus m2. But net force, actually we can say here, the on the m2 body the force will be downward, which will be equals to m2g, and on the m1 body it will be m1g, right? Since m2 is greater than m1, suppose the acceleration of the body in this direction, and for this acceleration will be along this direction. Now if we talk about this force m2g, then m2g is already along the direction of acceleration and it is in the same direction, so we can write here net force is as m2g. But the next force m1g, m1g is in the downward direction while the acceleration is in forward direction, so there is no component of m1g along the direction of acceleration. So by taking the component of m1g along this direction, as we know, when we take the component, since it is the angle of 90 degree, m1g direction of acceleration, if we want to take the component of m1g along this direction, since it is 90 degree, so it will be m1g cos 90, and m1g cos 90 will be the component of force along the acceleration, but cos 90 is 0, so we can take here 0. But actually if we are not considering friction here, then we can say this is the net acceleration m2g upon m1 plus m2, but there is a there is a friction between surfaces. If this block is having tendency to move in this direction, then a frictional force will act on the surface in this direction. Suppose it is small f. Now what is frictional force is simply mu n. Since mu is given, it is the coefficient of friction, but n is not given. N is simply a normal force, and in this case normal force will be balanced by this mg. So we can write frictional force is as mu n. Mu is given, but n is balanced by m1g, so we can write mu into m1g. So here net force is m2g plus 0, the component of m1g along this direction, and frictional force which will be mu m1g, but it is in the opposite direction, so it should be written with the negative sign, so we can write here minus mu m1, right? So our net acceleration become m2 minus mu m1 bracket g upon m1 plus m. So simply when we are considering the friction force in the problems, then we should not ignore the frictional force, and when we are calculating the acceleration, just make the component of every time force along the direction of acceleration. Next problem, suppose there is inclined plane, it is the angle theta, and an object is placed on this. A pulley is attached at the corner of this inclined plane, and with a rope this block is attached over the pulley. The other block of mass m1 and it is of mass m2 is attached. Now simply we have to find out again the acceleration of the blocks. As we know, acceleration is simply given by net force upon net mass. Here again there is no problem with the net mass, it is simply m1 plus m2. But since we have to calculate net force, so one force is acting in over the m1 mass, which will be equal to m1g. Another force will act on m2 mass, which will be equal to m2g. Since we have to calculate net force, and if we are assuming that m1 is greater than m2, suppose acceleration of the system in this direction. Again, while calculating net force, it should be remember that force should be always along the direction of acceleration. If because there is a frictional force also, actually we are considering the problem based on friction. So suppose the friction coefficient is mu. if there is a friction and this block M2 is having the tendency to move in this direction, then of course the force will act on the block in this direction. Suppose it is small f. Right. Now net force. When we talk about the M1 force, here M1G force is acting in the downward direction, which is already in along the direction of acceleration. So we can write directly it as M1G. Right. But when we talk about the forces on M2, actually first force on M2 is M2G, but it is not in the direction of acceleration. So when we redraw it, suppose it is M2 and we want to calculate the component of M2 in this direction, acceleration of the block in this direction like this, and we want to calculate the component of force in this direction, right? So for finding out the component, we should know about the angle, as it is theta, and if we draw the perpendicular over the surface, this will be 90, right? And the remaining angle will be 90 minus theta. So we can say this angle is 90 minus theta, right? When we take the component of M2G along this direction, it will become M2G cos 90 minus theta, and cos 90 minus theta is also written as sin theta. So we can say it is M2G sin theta, right? So one of the force, which is M2G acting on M2, its component along the direction of acceleration is M2G sin theta, but since it is in the opposite direction of acceleration, so we have to write it with negative sign, M2G sine of theta. Next force is friction. Frictional force will be in the opposite direction of acceleration. So it is already along the direction of acceleration, so there is no need to take the component of frictional force. But when we calculate the value of frictional force, as we know, frictional force is always given by mu n. Since mu is given, there is no problem with mu, but what will be n? Actually, n is the normal force, and normal force can be, it will be like this will be normal force. Why we are calculating normal force? Since we want to find out the value of friction. So what will be value of normal force? Normal force is actually balanced by the component of M2G along this direction, right? Since the component of M2G in this direction, it was M2G sin theta, just we have find out, because since this is the angle 90 minus theta, so this was component cos 90 minus theta and sin theta, but we want to take the component of M2G in perpendicular direction, so we can write it as M2G sin 90 minus theta, and M2G sin 90 minus theta means M2G cos theta. So we can write that normal force is equals to the component of M2G in this direction, which is M2G cos theta. So we can write frictional force is mu n, and n is equals to M2G cos of theta, right? So here I can write, but again it is in the opposite direction, so with negative sign, mu M2G cos of theta, right? Again by taking G common, M1 minus M2 sin theta minus mu M2 cos theta upon M1 plus M2 G. So it is the value of acceleration. So these were some problem based on frictional force, means when we are considering frictional force. In last class we have done the problems based on when the surface was frictionless, and when the surface was frictionless, for the same problem the acceleration was simply m1 minus m2 sin theta by m1 plus m2. There was the m mu m2 cos theta, this term was not present there because there was no friction, but since there is, we are considering friction, so this term should be there. So this will be the net acceleration. So this is the simple way for finding out acceleration, net force upon net mass. Always while calculating net force, we should remember that always make the component of force along the direction of acceleration. If it is in the same direction, then just take the positive sign, and if it is not in the direction of acceleration, means in the opposite direction, just take the negative sign, and we can find out the value of acceleration. In last class we will do some another problems based on some other knowledge. So thank you students.